So these are two Mikaze sensors that are running a radio counter LEDs application on them. So you can see that the LEDs are lighting up. So what the application basically does is it starts a counter at 0, and every n milliseconds it fires a timer. The n value can be specified by the user, so say for 100 milliseconds, 1000 milliseconds, 2000 milliseconds, anything. So every n milliseconds it updates the counter by 1 and sends out the counter value to all the other nodes in the network. It broadcasts the value. And any node that receives this packet will read the counter value from the packet and display the least significant bits on the LEDs. So you can see that if it's a 0, none of the LEDs light up. If it's 1, the red lights up. If it's a 2, the green. If it's a 3, the green and the red, and so on. So other than the LEDs lighting up, we are not able to visually see any packets that are being wirelessly transmitted to each other. I'm going to show you how you can actually visualize these wireless packets using the PROVIZ tool here. I'm going to be connecting another sniffer that is running a base station program. So this sensor sniffs the air and gets all the packet details that is being transmitted and sends it over the USB interface to the computer. There's another program that receives these packets and sends it out through IP to this tool, which will then be visualized. I'm going to show you how the tool works now. In this video, I'm going to show you how the PROVIZ tool works to visualize the two sensors that we're sending the counter value to each other. Drag and drop the two nodes onto the canvas. I had given them node IDs 10 and 20, so I'm going to drag and drop two nodes with node ID 10 and 20 onto the canvas, and then I'm going to start a live network visualization. So what this basically does is it starts a listener, and I go and open the other program that reads the packet traces that is sent from the sniffer I showed you earlier and sends it via IP to the listener in the other program. So here I'm going to enter some basic sniffer details, which will tell which USB interface to look for and what the baud rate is, etc. I'm going to be, as you can see, I'm going to be sending it back to my own IP and give it a port number 8003 that this other program is listening at. So now we can see the two sensors that are talking to each other, and this is the pass data. So there's the payload information. As you can see, the counter is being updated from C2, C3, C4, C5, so on. That was the time, the destination ID, the source ID, and the payload. Now I'm going to turn off one of these nodes, and soon you can see a pop-up message that says that one of the nodes is dead, and as the video is still streaming, eventually you can see that only one of the nodes talks to the other node. Right now we were talking about live visualization, where there were real sensors that were talking to each other and we were sniffing data on the go. Suppose we had done this earlier and we had a packet trace that contained all the packet information that like we saw earlier. Then we can use that packet information to visualize the same network later on when we still don't have the sensors around. Here I'm going to drag and drop the sensors that were in the WSN. There are 5 sensors named 1, 2, 3, 4, 5, I'm going to drop them onto the canvas and give them the node IDs. And then I'm going to choose the file that has to be visualized. Here I'm going to select the packet trace that I want to be visualized. And you can see that the nodes are talking to each other. Next, I'm going to show you a demo scenario. So suppose you want to share information about your WSN with other users and you want them to visualize what you are seeing. Then you create this XML file that specifies where you want the sensors to be on the canvas, where you want them to be placed, what they are going to be doing, to which other nodes they're going to be sending packets, what the node IDs are, and so on. Now in this setup, node 70 is going to be the attacker. So the original path is going to be from 0, 20, 50, and 10. So this is going to be the original path. Node 70 is going to say, oh hey, send the messages to me too. And node 0 is going to start sending messages to 70 to 10. It advertises a path, and the messages are going to be sent this way. And we can see that node 10 also responds to 50, 20, 10, and 70. T was the original path, and 70 sends out advertisement saying, hey, I have a path to 10 too. 0, 70, 10 start sending out data. And 10 finally starts sending information to all the nodes in the network. I'm going to be showing you another feature where you can create codes to be run on the sensor based on a C language abstraction. Originally, these sensors run a NESC code, which is the TinyOS version of C, which is very, very difficult with its wiring and configuration details. So now I'm going to show you what the scripting language looks like. So I'm going to open a file that has already been created. So this contains a periodic timer that is started every 10,000 milliseconds inside the event timer timeout. So whenever the timer times out, it starts sensing the light. Inside the start sense light function, I'm going to actually get the light sensor value. I'm going to create a packet that has the source, which is the current node ID, and the light info value that I just read. And I'm going to send the packet to another node 3 in the network. So this is the basic program, and I'm going to generate code. I'm going to give it an application name, which is SenseLight. This will create TinyOS based code, that is the configuration and module files. That can be programmed onto a sensor or simulated on ARMNet. I'm going to open another similar file that was created in the scripting language. So what this does is every time it receives a packet which generates an event, then I'm going to read the packet details, which is the same as what I'm getting from the other node, which has a source field and a light field. So I'm going to be reading the light field, which is the light sensor value, and I'm going to add the first, the second, and the fourth bits to display the least significant bits on the LEDs. Again, I'm going to generate code, giving it an application name, so radio to LEDs, and code was generated. Now suppose I did not have the hardware and I wanted to simulate it in NOMNet, then I'm going to give the number of nodes that I want to simulate in the network. I'm going to give the WSN name, say scene 1. I want to create a network called scene 1. Node 1 is going to be programmed with the application name sense light that we created earlier. What it's basically going to do is read light sensor value and send it over the radio. I'm going to give that node a node ID 2. The second node in the network is going to be doing the radio LED application, that is reading the sensor value that is sent over the radio and showing it to the LEDs, and I'm going to give it an ID 3. Once I set up the network, then we wait for the simulation to be done. We are going to go visualize it like we visualize the packet traces or the live network visualization. So we gave the two nodes node IDs 2 and 3. I'm going to drag and drop them onto the canvas and start the simulation. I'm going to pass simulator data now and give the scene name that we previously mentioned. Now we can see that the nodes 2 and 3 are sending. Next, I'm going to show you another feature, which is comparing packet traces. So suppose I have the two PST files that we were visualizing earlier, and I want to compare the two networks in the tools based on these properties: the number of packets, number of bytes per link, packet size, packet delay, periodic transmission. And I'm going to give number of packets weight as 30, periodic transmission as 70. We can see the two networks. The missing links are in red and the extra links are in blue. So on right clicking any of the links, I'm going to be able to see the two properties that we had given weights for earlier. So on the left side, the properties for link 4 to 2. On the right side, the properties for link 4 to 2. You can visually see how the properties differ. And if a missing link is clicked, we can see that since the other graph doesn't have it, no data is displayed. So based on these weights, the tool is going to compare the two networks and give me a percentage value that matches. Next, I'm going to show you the visual programming piece. So this is to create very basic sensor network programs. So as we saw earlier, I'm going to do the same, read the light sensor value, send it over the radio, get the light sensor value over the radio and flash it to the LEDs. So you can see now I'm sending the light sensor value over to the radios. I'm going to be repeating this action, that is on a timer based time every 500 milliseconds, and I'm going to give the node a node ID 7. I'm going to reset the tool and do the same for the other node, that is get the radio value over the radio, send it to the LEDs, give a node value 9. Done building the sensor. Once I'm done building the sensor, I'm going to drag and drop these two nodes and connect them as I want to. This will generate code in the scripting language that we saw earlier for the two nodes. So node ID 7, we're going to go now and see what the code looks like. So node ID 7 is going to have something similar to the SenseLight program that we saw earlier. Node 9, something similar to radio LED. So I'm going to choose node7.txt. And so once we have this code, we can make edits to it. and program it over WSN by generating TinyOS code or simulate it in Omnet.